In this animation, we will consider the enthalpy changes and temperature changes associated with exothermic and endothermic reactions. So we will start with an exothermic reaction. In this beaker, an exothermic chemical reaction will take place between two colorless liquids inside the beaker. So these are the reactants. Let's watch what will happen to the thermometer in the beaker. So we will start the reaction now. The reaction started, and now we will obtain the products of this reaction. This table shows information about the internal energy of the system before and after the reaction. So the internal energy of the system before the reaction was high, and after the reaction it is low. The standard enthalpy change delta H is negative, and thus this reaction is exothermic. Let's examine now more carefully what will happen. So we will start the reaction. So the temperature is now at a maximum. So what do you notice about the temperature change in the beaker as a result of this exothermic change? Yes, you are correct. The temperature of the system increases. If the beaker was insulated in order to prevent any loss of heat to the surroundings, what would happen to the temperature of the system at this point? Exactly. No change of temperature will be observed, so the temperature would remain high. However, the system shown here is not insulated, and this means that the temperature will not remain high. Notice how the temperature is decreasing. So at the end of this process, what do you notice about the energy exchange that takes place with the surroundings? Exactly. In this exothermic change, the system loses energy to its surrounding. So the system of the reaction will give energy to the surroundings, and this explains why the internal energy of the system after the reaction is low. This purple arrow over here shows this decrease in internal energy of the system. So an exothermic reaction is a reaction where the internal energy of the system after the reaction is less than that before the reaction. Energy is transferred from the system to the surroundings, and the standard enthalpy change will be negative. Let's examine now an endothermic reaction. So the reactants reacted together, and now we will obtain the products. So the internal energy of the system before the reaction was low. However, after the reaction, it's high. So delta H, or the standard enthalpy change in this case, is positive, and this is an endothermic reaction. Let's examine more carefully the process. So this is the system where two colorless liquids will react in an endothermic reaction. Watch the temperature on the thermometer reading. So the temperature decreased to a minimum. What do you notice about the temperature change in the beaker as a result of this endothermic change? Exactly, the temperature will decrease. If this beaker was insulated in order to prevent any transfer of heat from the surroundings, what would happen to the temperature of the system at this point? The temperature would remain low. However, the system shown here is not insulated, and thus we will have heat exchange with the surroundings. Let's observe it together. So notice how the temperature is increasing. So at the end of this process, what do you notice about the energy exchange which takes place with the surroundings? Exactly. In this endothermic change, the system gains energy from its surroundings. And this purple arrow over here shows the increase in internal energy of the system. An endothermic reaction is one where the internal energy of the system after the reaction is greater than that before the reaction. Energy is transferred from the surroundings to the system. and the standard enthalpy change of this reaction will be positive.